I'll take a photo of the exam, practice exam if you don't mind.
Oh, I don't mind. That'd be good. That's a good idea.
That way,
Do it Friday then.
Yeah, that'd be good. All right, let's take a look. There's a max-min problem. We have to minimize the sum, x plus y squared, where xy equals 100. That's a constraint. That's a constraint imposed on the variables. It says that xy has to equal 100. In addition to that, x and y have to be greater than or equal to 0.
That's what confuses me.
Okay? What's that?
X, Y equals 100.
Yeah, x times y is equal to 100. Their product must be 100, these two numbers. Okay? It's a limitation imposed on the variables. And that's what we're saying. It's what's going to enable us to get the quantity to be maximized or minimized in terms of a single variable, which is what we must do. Damien?
It says x and y is greater than or equal to 0.
Yes.
X or y was 0, wouldn't it equal 100? I mean, 0?
If x is equal to 0, we cannot have the product equal to 100. You're absolutely right. All I'm saying is, well, let's keep it positive. In other words, you can't have x as negative 10 and y as negative 10, which would be 100, and then you would have a product over there. Let's keep them both positive. But you're right, they can't be equal to 0, because you couldn't get the product equal to 100. But they could be negative. That's why I specifically rule that out. Okay? It's a good call. All right, find p in terms of x. What that means is you're going to have to solve for y and substitute it in here. The y is 100 over x squared. Okay? Now, what Nick did is solve for y, and I got to tell you, in this problem, you're probably better off solving for y. But I specifically asked for p in terms of x, so that's what you have to do. But he did it the better way, actually. All right, find all critical values. Where do critical values occur? Critical values occur where the derivative is equal to 0 or the derivative does not exist. Okay? Well, let's find the derivative and set it equal to 0. First, let me rewrite it. And 100 squared is 10,000 over x squared. So you easily will get a 20,000 kind of a thing. The derivative then is 1. Now consider this 10,000 x to the negative second. The negative 2 comes out front, so you get a minus 20,000, just what Trent said, over x cubed.
That's what I had.
And you're going to set it equal to 0 to find those critical values.
That's what I was just staring at.
Well, we can do this. Let's multiply by x cubed. Get rid of that fraction. Add 20,000 to both sides. And take the cube root. Well, let's see. What do we have? 1,000 is a perfect cube, okay? So the cube root of 1,000 is 10, all right? So what I'm going to do is take that 10 out. And that's what I'm going to have. That's the simplest form, okay? 10 times the cube root of 20. Find all critical values. Well, there's one critical value. We have another critical value where the derivative does not exist. The derivative does not exist at x equals 0, okay? But at x equals 0, like Damien just pointed out, we can't get x times y to be 100. So that's a value we have to just plain eliminate. Okay, it can't meet the constraint here, so x equals 0 is not a possibility. So we have one critical value to consider, 10 times the cube root of 20. That is going to be the x that minimizes the sum, but we should verify this with a second derivative test. If this is all I ask you on the test, you have one critical value, that's it. You should still probably verify it with a second derivative test. Let's do it. Let's take the second derivative. Derivative of 1 is 0. The derivative of 20,000 x over x cubed, you should think of this as 20,000 x to the negative third. The negative 3 comes out, makes it positive. Okay, 3 times the 20,000, x to the negative fourth, which is x to the fourth. That would be 60,000 over x to the fourth. That's the second derivative. Well, when you substitute this value in for x, it doesn't matter what it comes out to be. You don't have to actually do this to the fourth power. What does matter, if this is positive, that's positive, and that second derivative is positive at that value. That means it's concave up, and that means we have a minimum value, and that's exactly what we're looking for. Okay? And we're done. Now, if you had to actually find what that minimum value is, you would take your x value, solve for y by substituting in here, and find x plus y squared. Okay? That would be the minimum value. Damien?
Let's find the x that minimizes the sum.
Yes. That's it. This is the x that minimizes that sum.
Because that's the minimum value,
Yes.
which is also a critical value.
Yes, it is. Yep. Okay? All right, do 17 through 20.
So 60,000 divided by x to the fourth is the minimum value?
No. The minimum value occurs when x equals 10 times the cube root of 20. That's where it occurs. The minimum value of the sum is, here, what you would have to do, the actual minimum value of this sum is x, 10 times the cube root of 20, plus y squared. Well, what the heck is y? Y is 100 over x.
What are we doing right now? I'm sorry.
I'm telling Nick that the actual minimum value of that sum is, substitute for x, 10 cube root of 20, plus, now substitute for y, here's y, 100 over x. The question doesn't ask you to do this, okay? But I'm finding the minimum value, okay? The y value is 100 over x, 100, here's x. This is the y value, and we're going to square it. Whatever this comes out to be would be the minimum value.
That's
Okay.
something you wouldn't ask an exam about.
Not for a problem like this. I would not ask you for that. And the test, I think the problem's a lot easier, and I may ask you for that minimum or maximum value. But for this, it's kind of a pain. It's algebraic nightmare.
That's the minimum value for p,
Yes, it is.
but that's not the minimum value for x.
No. X, okay, the minimum value for p occurs when x is equal to 10 times the cube root of 20. What is that minimum value of p? Well, substitute in for x, substitute in for y, square the y. This is the minimum value of p. It occurred when x was 10 times the cube root of 20.
Now we take the second derivative to,
Verify that we have a minimum value.
so if they're both greater than 0, that would confirm it? Or
Say that again now?
how does that confirm it?
If the second derivative at that critical value is positive, which it is, we have a minimum.
Concave
Up. Yep. Correct.
Just the zeros matters, right? If they're both greater than 0, then they're good to go.
I don't like that statement. What's greater than 0?
If the first derivative was less than 0, and the second derivative was less than 0, then that would confirm it, or?
Okay. The first derivative has to be equal to 0 to give us a critical value, first of all. Then, when the second derivative at that point is positive, which it is, that tells us we have a minimum value there.
Oh.
Okay?
So wait, find the p in terms of x, what would the answer for that one be?
That's what I did. I found p in terms of x right here.
That's p in
In terms of x. That's the answer to number 13.
That's without taking the derivative.
Correct.
Okay, and then 14, find all the critical value. We know it's 0, 0 doesn't work.
That's right.
Because there's no such thing. It can't happen.
That's correct. Here's the only critical value right here.
And find x to minimize the sum.
And that is the x that minimizes the sum.
So
That's the same answer. For
Same answer?
13, 14 and 15 have the same answer. Because there's only one critical value, and it is the minimum. It's where the minimum occurs.
So in other words, if say 0 was an option, 0 would be that x that minimizes the sum, right?
If 0 were an option, it would be a critical value, but it may or may not be a minimum there. Depends on the second derivative.
Well, if it's positive like that.
Oh, then it would be. But there's only one absolute minimum value. So if you have two relative ones, you're going to have to compare those two to see which one is indeed the minimum. Well, we won't get to that.
I know, but I'm just
Yeah.
saying.
Damien, you all set?
If there were two critical values, which one would be the minimized, like which one? would-
Well, almost always what happens, and certainly the problems that we do, if you have two critical values, one's going to give you a relative min, one's going to give you a relative max. And so there won't be a problem there.
Take the second or the second.
Yeah, yeah, yeah.
Can I have a piece of paper? I'm too lazy to.
Oh, just a blank piece?
Just a blank.